Hello friends, welcome back to my channel and let us go through a nice problem which involves topics like convolution, convolution property of the Fourier transform and also the evaluation of the area of a signal. So let's jump into the problem. The problem statement goes like this. We are given the signal x1 of t, which is unit step function shifted to the left by 1.5 units, and we are subtracting another unit step function shifted to the right by 1.5 units, and the signal x2 of t is as shown below. So what happens? So signal x2 of t has two Dirac delta functions at -3 and -2, and the Dirac delta at -3 and +2, and Dirac delta at -3 has an area of 1 unit, and the Dirac delta at 2 has an area of 2 units. And we have a rectangular function from -1 to +1 with an amplitude of 1. Okay, so now what is the question? So we are asked to evaluate the convolution of the two signals x1 of t and x2 of t, and it is called, the final output is called y of t. But the question is, we have to evaluate this integral, which is given by integral minus infinity to infinity y of t dt. So you can easily recall from your calculus that this is nothing but the area of the signal y of t. So what is the final question? Given x1 of t and x2 of t and y of t to be equal to x1 of t convolved with x2 of t, evaluate the area of y of t. So that is the question. X1 of t is given here and x2 of t is given here. So let us look at the solution. So we will, to evaluate the solution, we will take the help of the Fourier transform. So how is Fourier transform of a signal y of t defined? It is defined as y of f is equal to integral minus infinity to infinity y of t e power minus j 2 pi ft. Now let's look at what happens if you replace f with 0. If you substitute f with 0, what do we get? So we get what happens to this integral? So that is what I want to mention. Integral minus infinity to infinity y of t e power minus j, f is replaced with 0, so you'll get e power 0, which is nothing but 1. So finally you get what? Area of the signal. So how do you get the area of the signal y of t? By replacing f with the 0 in the Fourier transform of that particular signal. Okay, so this is very important result, and we will use it to evaluate our area of the signal y of t. Okay, so what is given to us? We are given that y of t is nothing but x1 of t convolved with x2 of t. Now by taking Fourier transform, what happens? We know a very important property, that convolution in time domain corresponds to multiplication in frequency domain. So if x1 of t has x1 of f as a Fourier transform and x2 of t has x2 of f as a Fourier transform, then the Fourier transform of y of t given by y of f should be equal to the product of x1 of f and x2 of f. Now you just recall that we are interested in evaluating the area of y of t, which is nothing but Fourier transform of y of f, Fourier transform y of f evaluated at f is equal to 0. So what happens if you substitute f is equal to 0? We get y of 0, which is nothing but x1 of 0 times x2 of 0. But we already know that the area of I mean, we already know that y of 0 is nothing but area of the signal y of t, but we will use the same result in this also. What do I mean by that? What will be the x1 of 0, capital X1 of 0? That would be area of x1 of t. Let us call it a1, and x2 of 0 would be area of x2 of t. Let us call that to be a2. So what is that we got? We got that y of 0 is nothing but, capital Y of 0 is nothing but area of x1 of t, which we called it a1, multiplied with area of x2 of t, which we called it a2. Okay, but what what is x1 of t? X1 of t is given to be u of t plus 1.5 minus u of t minus 1.5, the plot of which is given here. So it will be a rectangular signal from minus 1.5 to plus 1.5 with amplitude 1. And recall that x2 of t is shown in this figure. So what will be the area of x1 of t? It is just a rectangular function from minus 1.5 to plus 1.5 with amplitude 1, and hence that fellow will have an area of 3 units. And similarly, what will be area of x2 of t? It is nothing but area of this Dirac delta, which is 1, plus area of this rectangular function, which is 2, and the area of this Dirac delta, which is 2. So totally what will happen? We get area of the signal x2 of t to be equal to 1 plus 2, which is equal to 5 units. Okay, so recall that we have got the area of the function y of t to be equal to ay, which is equal to capital Y of 0, and that we showed that it is equal to capital X1 of 0 times capital X2 of 0, and which in turn is equal to the product of the corresponding areas A1 and A2. But just now we got that results to be 3 and 5 respectively. By just substituting them, we get Ay to be equal to 15. But what is Ay? That is nothing but our area of the signal y of t, which is nothing but this integration, which is nothing but the evaluation of the question asked. Hope you have understood the concept of evaluation of the area of the signal by taking the help of the Fourier transform. Thank you.